Hello, everyone, and welcome to another episode of Observable Flutter. My name is Craig Labenz, and I'm your host. And today we're going to try to make a poorly performing game loop perform just a little bit better. And I'm pretty excited about today's guest because few people on this earth know more about Flame than today's guest. So, very, very exciting. Oh, this is the wrong slide. I just realized it's not November anymore. Oh, yeah. Today's the 30th stream. I'm good at this. Anyway, we're going to move off of that stale slide. Folks, this is the Flutter community. Let's keep that top of mind. We've got our sterling reputation for warmth and welcomeness. Welcomeness. I doubt that's a word. That reputation, very important to me. I hope it's very important to you. Let's maintain that and be wonderful to each other. Okay, today's guest singular, foreshadowed slightly. Lukas Klingsbo, core contributor to Flame, employee at Blue Fire, I believe. I don't really know what else Lukas does. I'll let him tell you. Lukas, welcome to Observable Flutter.
Hello, 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 hello. Yeah, I'm Lukas. I'm in Stockholm, and I'm not really an employee of Blue Fire since we don't have any money, but we are just an open source collective, so we build a lot of packages and stuff for the Flutter and Dart ecosystem. Yeah, and mostly my like focus is Flame within Blue Fire. So I know a bit about it.
Okay, great. And Lukas, I think there was one other two-time guest at the very beginning of Observable Flutter, another DevRel person from Google Pay joined twice because the first stream I wasted the whole time trying to debug my Android emulator. And then he came back the next week and was like, watch an adult do this. But I believe you are the first actual two-time guest to come back just to talk about another thing. So I'm very honored that you're taking time out of a second evening to join.
Oh, I am very honored. It's a lot of fun to be here.
All right. So first things first, Lukas, this weekend there is a thing going on. Would you like to talk about it?
Yes. Yeah, of course. So this weekend we have a Flame Game Jam. And if you don't know what a game jam is, you just get together with, or you don't have to get together, you can write your own game too. But it's usually more fun if you're in a team. And you have from Friday evening tomorrow, or evening in my time zone, to Sunday to build a game on a theme that is secret so far, but tomorrow we will announce it on our stream that you can find on this itch.io page. And there are lots of nice prizes that you can win. So we have like $500 cash prize, $500 of like different snack boxes that we're gonna send out, and we have 20 dashes that you can win. So there will be a lot of people winning dashes.
Whoa.
And yeah, check out our itch page and join our Discord because that's usually where all the fun is happening.
Nice. Well, that is going to be very fun. I'm hoping to even participate myself, though.
I hope you will.
There's very little chance whatever I make would win a prize, would be in the top 3, but I won't be in the running anyway. I'll just recuse myself from that, which is, that'd be like if I was like, don't worry, NBA All-Star Game Selection Committee, I recuse myself from you picking me. They're like, yeah, we weren't going to. But
it's all about the journey, right? It's more about having fun while you're doing it.
That's right. King Hater, with a spelling that is not Heter. Very excited to watch this and see how the professionals make the code work better than it already does. Well, I'll let you know when we find some professionals. And I'd like to watch how they do it too.
Same.
Yeah, gosh, that'll be so interesting. You are not alone in wanting to watch that. Okay, so let's dive into it. Do you think? Are you ready, Lucas?
Absolutely.
Okay. So, in a random file, looks like it's zombie.dart in the project, and let's begin by running it again. And that's not how we do it. Let's look at what's going on, and then we'll see the problem. The problem won't be obvious right now because I think there's only 10-ish zombies, and we saw it last stream when I set that number to 100. So it should be crisp right now. Then we'll switch it to 100. I also don't really know what the frame rate is like over the stream. It's not I don't know how obvious a bad frame rate is. Hopefully, well, it's weird, hopefully it's obvious so that people can see what we're fixing, but also hopefully it's not obvious because that's, the app is really broken. But anywho, so everybody's walking pretty smoothly right now. The zombies are taking their little steps. They're being so cute. And that's all good and fun. But in world.dart, in a world where there's more than 10 zombies, this summer, 100 zombies. All right, so file is saved, rebuild. And now, it's got to be obvious, right? That the frame rate is terrible.
Yeah, I think so.
Yeah, it's pretty stuttery.
You can definitely see that it's worse than it was before.
Okay, great. Great in that I'm not actually sure it's a great way.
So what we can do as a starting step, there is a component called FPS text component, and you will actually see up in the corner what the FPS is.
Incredible. I've been that was one of my first questions, except I was about to forget to ask. So brilliant. Let's see. Let's also spread them out a little more, and then we can really get. I think some off-screen zombie optimization could also be interesting. I don't have any of that. I don't think. Well, they leave the following state once they're a certain distance from the player, and then they wander aimlessly, and that may involve less CPU time to compute their wandering. So maybe I have off-screen zombie optimization, but anyway. So FPS, yeah, let's do it. How should I add that to the overlay? What's the right place to do that?
Can add it to the viewport is the easiest. So I don't know if you have, so it's camera.viewport.add.
Okay, I think camera, yeah. Okay, so setup, is this in the, probably, onload of the world. So it seems like maybe right here is the place to do this.
Yeah, you can do that.
Okay, game ref, camera, component, dot, and then viewport, you said?
Yes. So then it will be like a HUD, like on top of everything, even though you move it around in the world.
Oh, right. Yeah. So the viewport, I always, when I'm remembering enough to think about it clearly, what I try to picture is like if you're, looking out a circular window in a ship, the viewport is literally the frame around the glass.
Exactly.
Right?
And in Flame, you can even have circular viewports. You could build your own little submarine window or something.
We can have an infinite line of fish stretching deep into outer space. So yeah, we need the FPS. Is there? Oh goodness gracious!
FPS text component. So the first one doesn't show anything; it just calculates it. Yeah, and that should put it in the upper left corner automatically.
Oh boy. Okay, so we're there now. It's very clear. 20, not good.
Exactly.
Can it run Crisis? Yes. Can it run this zombie game? No. Just not ideal. So now let's go back to 12, which was the original number, and see how that
what the difference
looks.
is,
Okay, so we're sitting at 60, which is the cap of my monitor, but I doubt Flame is capping itself. Why is it sitting at exactly 60? Does Flame just throttle itself at 60?
I mean, the Flutter won't update faster than your system can handle. or that the hertz is of your monitor.
Yeah. Okay. So Flutter is paying attention to my monitor and not asking. Okay. Great.
So you could have 120 FPS too if you would have a faster refresh rate.
Yeah. I expect, this could climb very high. Okay. But at 100, it does not climb high. So it is time to debug. Now, there's different, first we could try to go in as if we had no theories and like measure things and knife in that way. We do have some theories, as we were talking about before the stream. I also was hypothesizing last stream on what the problem might be. So do you think it makes sense to contrive, pretend that we're clueless and try to investigate, or just
we
go
could, but I think we can just start trying things first, and then we do more thorough investigation if we get stuck. But if anyone needs to do this thorough investigation, we have a new component also called, what is that called again? So Eric created another debug component, which is for measuring times, so that you can have a component that just keeps track of when things start and when things end, which is quite useful. So
is that a mixin?
If you scroll up and check the imports for the FPS text component, so that it should be. So not in that one, in the imports, then it should be importing some debug thing inside of your zombie or in your world.
It was already maybe.
Okay, maybe it is in components too. Okay. If you look here and then you go one step up from here.
Okay.
Oh, you're on a very old version of Flame.
Oh, I am. Yeah, I made this game a long time ago and haven't updated Flame in
if we have time later, we can do that. That will be an interesting.
Yeah. All right. So we'll set aside that new component because I don't have it. That also explains potentially why the import thing behaved differently.
Yeah, exactly. Because that FPS text component is moved to debug barrel file, I think, and that's where I would see the name of that one. Oh, thank you. That's the name. So this is Eric's wife.
Oh. Wow, really following Eric's work. My wife and I do not know about each other's work with that level of granularity.
Or Eric is writing from her account, who knows?
Big brain. One person, so Kyle points out, you don't actually need Flame to implement this game. That's certainly true.
I mean, you only need a canvas to do anything, right?
Right.
But Flame will help you a lot.
Yeah, exactly. Yeah, you don't need Flame to implement anything in Flutter. Technically, you don't need Flutter to implement anything below it, right? You could do it with just Dart UI.
Why not write it in assembly?
Yeah. But the and we're being cheeky, but you can get very far with vanilla Flutter. Flutter already has a ton of great abstractions. But yeah, Flame certainly layering on more very helpful abstractions. All right. So now
we start looking at how the zombies are moving.
Yes. And then we will work on our theories. We can comment out code where stuff is happening and see what changes. So in the update method, there is and I think they have a component. So unwalkable terrain checker is one of the things. So let's just first look at what unwalkable terrain checker does. The player and the zombies both use this. So and this is in this check movement method. Before, I'm just going to remind myself where that's actually called. So why is it called twice? Wait, are you for real? Well,
Oh.
this. Oh, wait. There's a different predicate thing. Is unwalkable terrain. Oh, I remember now. Yeah, this was how we made the zombies not step on each other. Other zombies are unwalkable terrain.
Right.
Yeah. Okay. We could potentially, one bit of optimization would be to just have a function that ORs this so that the rest of the logic doesn't have to run twice. And we can just have a smarter if check in the loops of the check movement.
So I would start with uncommenting the second part there, just the is zombie thing. And
Okay.
because if you have 100 zombies and if this is not done in an optimized way, then you will have 10,000 checks, right?
Yeah, thankfully it's not doing that.
Okay.
But let's see how this behaves. All right, so we did get back about 7 FPS from that.
No, not much. It's definitely something bigger.
Now it's going back down a little bit.
Yeah, that seems like you have implemented that quite well. The other thing, since this is the same as it was before, I think.
Yeah, and it's funny, actually, as I move around and pick them up, because I spread them out a lot, and as the more of them are entering the follow state, the FPS is plummeting.
So you probably have, it is probably more efficient when they're just wandering around than when they are close enough to you to follow you.
So and let's see, I'm picking up some more here. Yep, FPS is continuing to go down.
Yeah, that gives us a hint what the problem is, at least.
Yeah. Okay, so I'm just going to let that continue to pointlessly waste CPU resources.
Yeah.
So the way that worked, by the way, is it just uses, so we pass in the original position and how much they moved this frame. And there's ways that this can glitch. It's really not that smart. But the basic idea is if the character was moving up they could be moving diagonally, of course. But if there's an up component to their movement vector, then we check, is the top center in an illegal spot? So we're querying the game world, and this method from Flame is nice and efficient. And then we just call the predicate that was passed in on any component at that point. And if the predicate says yes, then we zero out their movement in that direction. We do that for all 4 directions. So there's actually not even a loop other than the one inside, the one that recurses the component tree in this method.
Right.
So it basically just checks if a zombie tries to walk forward, it's like, am I clipping another zombie in this spot, which is an efficient lookup, thanks to you, Lucas. And then if it is, it's like, well, I can't do that.
Yeah.
So that's how the check movement method works. And we can see that wasn't our culprit. So actually the reason, remember, we got back like 8 or 9 frames initially. And I thought, I think this was helping some. I don't think it was helping.
No, it was just randomly that we had less zombies close to us.
Well, I widened their spawn range. So we definitely had less. And then as we walked around, we picked them up. They left the wander state. So I think all signs are pointing to check movement immaterial. We can close the file. Yeah. And it's the follow state versus the wander state. So back to update, we can see here, wander or chase are the methods that we call. So the problem is in chase, it seems.
Makes sense.
So the couple concepts here, this method apply veer to path. I don't think this is going to be the issue, because apply veer just says like zombies kind of stagger and tilt left and right of their actual goal. They don't just perfectly hone in on their target. No. So this applies a oscillating 45 degrees to the left or 45 degrees to the right. It's just like constantly spinning and moving their pathfinding along this kind of cone. And we can see what it's doing here. Basically just kind of animation controller-y stuff. Some logic that looks annoying but isn't going to take a long time to run. And let's see, what's this doing? Path, vector 2, rotate. No, this is all fine. We just return a line. So I don't think this method is the issue. Do you agree, by the way?
Yeah.
So what does set veer do?
If anyone else wants to do this, we have effects that you can
better
run
way.
with noise. Yeah, so that you don't have to write all the code yourself, at least. So we have so this is a classic thing where you implement some noise, and it can first have the straight line, and then as an effect, and then you have noise added to that so that it doesn't go in a straight line. Can be
Brilliant.
Nice.
Yeah.
But yeah, let's continue.
So debug pathfinding, this just draws a line if they're in debug. So that's probably not it. Also, we see that no lines are being drawn. So they're all their debug values are false. So move along path is got to be where the problem is happening. Okay. Get unwalkable collision. I'm going to skim ahead real quick, and then apply movement and apply lurch does also have some more stuff. It's not going to be apply lurch. We can talk about that as well. I'm going to remind myself what get unwalkable collision does. As you can see, I'm really smart and I didn't write any comments. So, a loop here. So potentially not good. So what this seems to be saying is, now these unwalkable component edges, oh, nice. Look at that. They're just dogpiling. 0 FPS.
It must, I mean, it's clearly doing something. So
it's
above
gosh,
0.
It's so choppy right now. This is funny. So the unwalkable edges are currently being rendered with this red line. And so we're checking for a red line. We're looping over all the red lines in the world, no matter how far away from us they are. So this is obviously we're off to a maybe optimizable start.
And
now,
how
there's not a ton in the world yet.
Yeah. How long is that list?
It's right now, I think the only 3 unwalkable things in the whole. Oh, they're tunneling like crazy, by the way. That's another thing to optimize. That's why they keep coming in from far away.
Yeah, the more the FPS drops, the more you will have tunneling. So for the people that don't know what tunneling is when you have collision detection, but either your object or your component is moving so quickly that it will, between one frame and another, it will go straight through a hitbox. Or now when it's lagging, then it can jump through a hitbox, because if they don't overlap, it won't be a collision detected.
Right. So you calculate how much you should move every frame based on the amount of time that's passed since the last frame. And normally that's about 16 or 17 milliseconds. But suddenly for us right now, we're sitting at 333 milliseconds. So we're calculating, way more, 20 times the movement. And yeah, so you can, from one frame to the next, if you have a narrow hitbox, you just teleport to the other side of it. That's tunneling. But it also happens when I put OS operating system focus on a different app, and then I come back, and then my delta time is like, potentially a minute, and they just shoot all the way to the end of the map.
So when you update the Flame version, you can set the flag to solve that, so that it throws away things when it doesn't have focus.
Wonderful. This is just so silly right now. What a good game. Let me tell you. Okay, so we're looping over the thing. Oh yeah, I switched back to this. You were asking. See, we just saw some tunneling there. I left the game briefly, came back, and they all kind of scattered. So we've got, what is it? 4 here, 5 here. Anyway, there's like 10-ish in the whole game world.
Not a lot.
So nope. But we're doing this 100 times. This loop for 10 things, and then so the question here is, we've got this path to the player, and does that intersect a line? My thought was, this is basically their pathfinding. This is it. There's no A star, nothing like that. They just have a straight line to the player. And if something is in their way, they will just pick the end, like one of the corners of that line, and walk to that instead.
Makes sense.
And if that gets them stuck, they're zombies, they're stupid, they get stuck. If that ends up, they can walk around something, cool. So intersects at, so this returns a point if the path to the line intersects the unwalkable line. And then if the intersection is not null, so that means we can't, this path won't get us to the player. So then I want the shortest intersection as well. So the idea here, let's say the player is like at the door, the zombie is up here. It's going to both collide with this line and it's going to collide with the line at the bottom of the house. And the check here is basically just saying, worry about the nearest line. So the zombie is going to path to the one of the ends of the line. So it's either going to go to the right side or the left side. So the top of the house, try to work its way down. The logic that we're looking at right now prevents it from trying to path to this corner or this corner, which would still be broken because it would still, of course, clip. So that's what we're looking at here. So this says, are we intersecting with the basically the nearest unwalkable edge? And then let's see here. So if the thing, so we're getting the shortest length. Is this? I expected to see something at the end of the loop.
What we could start with is just completely turn that off and see if that affects anything. So we know if that's the culprit.
Smart. So the path to player is, so we're taking in a line. I don't know why I didn't put the type here. That was, anyway, so we take in a path, we return a path. So if we just return the path, then we have functionally commented this out.
Yeah, perfect.
So let's see. All right.
No,
Not the issue.
Seems not the issue.
Not
That's good.
the issue.
Then we know that at least. And now they're walking through your house over there.
Yeah. Oh, but if they spawn, this is a fun thing. If they spawn in the house, then no movement they take is legal. So they're just stuck.
They live there now.
So,
but wait.
Oh, wait.
If you have commented that out now, why are they getting stuck?
So they just don't path toward the corner, but they still can't. They still can't take illegal actions. So the ones on the end are just kind of like liquid dynamics almost flowing over the edge, but these people in the middle have no concept of pathing to the corner.
Yeah, makes sense.
So that's what's happening. All right. Anyway, that's not the issue.
So let's try commenting out the unwalkable path thing then.
Which part are you talking?
Or the one that they can, the one that checks all of the tiles that it can't be on. So that like now when we saw someone being in the house, so that is legal moves. Those are legal moves.
Yeah, that was in like check movement. Check. Oh yeah, here we go. That was this one.
Yeah.
Right. So earlier we commented
one,
out.
right? Yeah.
Yeah. But it's the same logic. So
so it should be fine because it's even less of those ones, right?
Yep. But again, the number of those is not relevant because of your implementation for component at location or whatever the name of the function actually is. All right. So now they've got whoa, interesting. With neither of those in place,
then
we're still smooth.
Okay.
Okay. So, we tried commenting out just this one before. So now we're going to do the opposite. They can't step on each other, but they can walk wherever except on each other. Yeah. I've not tried this before.
Feels like it would be the other one would be more heavy.
Wild. So wait a minute. Wait just a minute.
So it's dropping quite a bit there too, right?
Yeah. Continuing to go down.
Yeah.
But somehow having both of them is really bad. Yeah. Having only one of them, and it can be either, having neither of them is good. Having just one of them is bad. And having both of them seems to be as bad as having one.
That's so strange.
Oh, whoops. I meant to uncomment both of them. Yeah, so here they're both commented. We're at 60 frames per second. Wonderful. I meant to uncomment them both. So it's bad. No, I guess they're not equivalent. It does get lower faster with
Yeah.
both of them. We'd be at like 30 frames right now in the other
Right.
test.
What it could be is that we're generating so many vector2 components now for all the checks that it could be the garbage collector that is taking too much time. So we can see here if we have some ways here of fixing that.
Interesting.
So for example, a position of anchor, does that one take in any optional arguments? I've forgotten.
Nope.
No, only the anchor, because this one creates new vectors, even if it is.
Right.
Yeah. So what we can try, I don't think that one is the heaviest one. So let's check more where it creates vectors. Yeah, this one.
So the only other method, right? Components at point is probably the other thing we need to look at, right?
Yeah, because that one is really inefficient.
Oh, it is?
Yeah, it's not super efficient, I would say.
Okay, interesting.
Because
this was drilling through the tree, I had assumed it was going to be pretty smooth.
No, I mean, it goes through the whole tree there, so it's
not just
really...
the subtree?
I mean, the subtree of the world.
Of the world, so it has everything.
Things, so yeah.
Okay. So we nested points. Do you remember what this is? Is this an optimization opportunity?
No. So that one, so this is a recursive function that goes further in, and then it sends like the trail of where it has been kind of down the tree.
Got it. Yep.
So that one we don't have to do anything. But let's check it original code and we can see what we have in there.
All right. So yeah, we're looping over the children. Point. This is the point that was passed in, right? So that's the child. Oh no, because we're recursing. And then if child is coordinate transform, I have position components. Are they coordinate transforms?
Yeah.
They are. So this does happen. Now parent to local. So we'd go to the position component and check their parent to local implementation.
Exactly.
Transform global to local.
So it just goes through the whole tree and like check where they really are, kind of.
So this part isn't going to be a problem, I don't think.
No, that is optimized. But here it creates a new vector object here, so that could be bad. But what we could do is do some simpler things instead that doesn't have to make us care so much about this in these internal implementations. And right now, they check. Let's see. So now they're checking all the time where if they can walk on the next square, right?
Yeah, every time they try to walk.
Yeah. So we could try to cache that. It won't work for the zombies to cache that though, only for the static.
Right, because they're moving
things.
Yep. Yeah, that's an interesting point, right? The unwalkable terrain per point. Yeah, that really could balloon the memory though, because you're going to build this map of like every possible location that a zombie has walked. And you'll either have a list of, it'll be an empty list in this really, really, really big map where the keys are positions.
Yeah.
The values are lists of components, or it'll be like one thing there.
How is the background built up?
Using tiled.
Right. Okay. So that should.
And then the flame tiled.
Yeah. Package. So it just has a tiled component as the background.
Yep.
We can do an interesting thing to just print the amount of children in the world. So, to see how much we have there, what we're going through.
So in probably update of the world, which is not.
Or you can just do it from your game, and just do world.children.length.
Gotcha.
After everything is added, you have your.
Does game have an update method?
Yep, it's also a component.
Oh, it just wasn't showing up for a second. Okay, so here we're going to print world.children length. All right. As Samuel L. Jackson so eloquently said in Jurassic Park, hold on to your butts.
And now there will be a lot of printing.
Oh, I do have to switch back to the game for it to start running. All right, so 137, that's not a crazy amount.
No, that sounds reasonable. But that's good. Then we know that.
And it's consistent. It's not like fluctuating up and down.
Yeah, so it's like 100 zombies and then some other things in the world.
Yeah.
It's good.
Okay,
so we know. Okay, let's check at the implementation of your method where you're calling that components at point again.
Yeah, so getting the top center of the component, that's after they move. So the way this works, check movement is applied, their movement has already been applied to their position. So position of anchor, this will give us like, if this movement ends up being valid, kind of a result. But then the original position is passed in so that we can use that for something, and I forget what. Let's find out, because I don't remember anymore. Yeah, like this is apparently passed in as a dead parameter.
Okay, so before it probably moved back to the original position if it was an illegal move, I guess.
Yeah, wait, what? Original position. Oh, I pulled that out of the code probably when I made this so it would run twice. This used to happen in the method when check method didn't need to be run more than once potentially. So this is a dead parameter and we can just get rid of it.
Let's remove it.
Okay. Hey, we're optimized.
What we could do more, so 100, so we will create new top there will create 100 and 100 new vectors per second, but no, 100 new vectors.
Well, 400 because we're doing this for all four sides. But actually, no, only if they're moving in a certain direction. In general, they'll probably be moving 2 directions, so 200 per zombie.
Yeah, per 16 milliseconds. And then we do the components as point there. So what
in general, just kind of thinking about like games, like bullet hell games, right? They must be creating just bananas amounts of vector 2s in their calculations all the time.
Yeah. So what they are doing is using the collision detection system instead, and because this is basically doing collision detection. So they set where they don't check every tick where they want to go. So they can have like, okay, I want to go over here, and then you hit something. And the collision detection is much more efficient than components at point. Because that one has something called a Broadphase that is running first. That removes everything that it couldn't possibly collide with.
So, okay, this is great. Kind of take a step back, reassess your philosophy thinking. The reason that I am even doing this and not using collision detection was maybe a kind of false problem. What I remember thinking was, I need to be able to undo movement if it would be illegal, but collision detection happens after the movement has already been applied.
Yeah.
And So
That is
yeah,
a
so
good
I'm
point,
running this
actually.
in the update method. Is there another way to do that?
Yeah, so there is a callback or a listener that you can register listeners to that is called on collisions completed. That is like, I might not even be released yet, but it's on the main. So there you can listen to that. But so I mean, when the collision happens, you can. So you move first, right? All of your
Move first.
move first.
Yep.
Then collision
Movement
detection
to frame
happens.
is. Yep.
So in the collision detection callbacks, like on collision start, for example, then you can keep track of. So in the update method, you can keep track of where you were the last step first, and then on collision started, you have access to that information and can move yourself out of the collision.
Got it. So what's the life cycle of these methods? What's the order of how these things are evaluated?
So first, update will run for all the components, and they will
Okay.
update their positions, and then
Okay.
after that, the collision detection kicks in, and after
that makes
that,
sense.
render kicks in.
Great. So this makes sense. Update, collision detection, callback for when the collision detection is done, which I would need to update my version of Flame to use. Is that
No,
right?
we don't. I realize we don't need that thing here. We can just use the callbacks since they are happening after update anyways.
Did my camera freeze, by the way?
Yes, I think it did. Yeah, it froze with a thumbs up, and it is displaying a thumbs up in your corner.
Yeah, I think this is the new Mac OS thing that is just like, come on.
Is it
I can't think of
optimizing
a
something for you?
sillier. Yeah, I can't think of a worse feature Apple has added in a very long time than the detection of a thumbs up and like, let me change everything for you.
What? It changes things when you do a thumbs up.
Yeah, on Sonoma, it like overlays. All right, I'm gonna stop my virtual camera in OBS. Yeah, OBS is like totally frozen.
Oh no.
OBS is really mad. But that's fine, actually. I can restart OBS. That's not going to interrupt the stream.
Yeah.
Okay,
Go for
I'm going to
it.
do that. Thanks, Tim. What am I doing right now? Reopening OBS. Okay. OBS no longer panicking. Start the virtual camera again. Here we go. I'm not making any more thumbs up noises, and then I'm turning that off after the stream. I'm never letting anyone talk me into turning it on again. It's in this window normally, but it's, here we go. Reactions are on. I don't want them on. Off.
Oh,
There it is.
nice.
Okay.
Finally, you don't have to cut off your thumbs. That's nice.
That was my next plan too. How do you know? All right. So as we were talking about, it's update, collision detection, render. Totally makes sense. I need to knife in to use the more efficient collision detection system instead of my home rolled hot garbage here. I need to knife in between collision detection and rendering so I can undo movement based on collision detection.
Yes, and that is where the callbacks already happens between update and render.
Getting a lot of calls for you for president. Are you aware of this? More than one.
It's fun that I know all these people too.
Yeah, I know Kendi. Wait, do I know Grayson? Grayson, do I know you?
I don't know, but he's building a really cool space game for his band. He has a really nice rock band, and he's building a space game for the band. It's really cool. And
Wow.
he has a lot more, like there are things flying around everywhere on his game, so he needs some optimization stuff there too.
Yeah, certainly he might need it if he's doing what I'm doing. So I'm still surprised components at point is maybe slow.
Yeah, I think so. So what we would do instead, if we would want to do it other way, then we would have to, so all these lines that you have now, they are not hitboxes, right?
Oh, no, they're not. Wait, are they? I don't remember. Oh, but we might have to add them. I think that's what you're getting at.
So because then we could check like where on the hitboxes it needs to go instead of going on the end of the line, kind of.
So I add an unwalkable component, and I think I also add the lines themselves. I guess not. Wait, unwalkable component edges, and then do I ever add the unwalkable component edges? I thought I did.
It's probably something you just look at maybe in your code. Maybe they're not
I
components.
believe are correct, sir. I believe you are correct. Yeah, I think you're right. And only zombies.
Yeah.
Zombies do that in their pathing, but it is not a part of this code, so that's not the issue. But we may, to your point, we may need to add these as proper components with hitboxes. So
yeah, so then you would have to turn these lines into polygons, but that's really easy when you have several lines, right? You just add them together as a polygon hitbox, or some of them might be circle hitboxes or something else.
Yeah, what is line actually? Oh, this is just a pure Dart class. It just has the start and end. That's it.
Yeah.
And then like methods that I needed that maybe exist somewhere else.
Yeah, I think a lot of people have written that class.
Okay, so this unwalkable component, this is what I'm looking for in the method in movement, when predicate certainly is like, are you an unwalkable component? So there's that, and then the other one was a zombie. So those could both have hitboxes.
Yeah.
And then this is the unwalkable component has literally nothing to it at this point other than to be able to be type checked. So we could add a hitbox to this.
Yeah, so the polygon component here, it kind of already, I mean, it is like a homemade hitbox kind of. The polygon hitbox is very similar to the polygon component in how you create it.
Okay.
So we probably wouldn't even need this class. You could just add a polygon component to whatever you want it to have a hitbox. No, not a polygon component, a polygon hitbox.
I see. And then this could be a position component or whatever.
Yeah. Are you adding things to the unwalkable component?
No, it is just to store.
Yeah. Then you just need to have the pre-built polygon hitbox. You don't need this component at all.
Okay. So what if I said, instead of polygon component, but just a position component?
A polygon hitbox. You could, if we want to keep this component, then we can write it as a polygon hitbox, and that would probably be a good idea to make the transition easier, I guess.
So hitboxes, you tend to add them to components, but can you just add them to the world? Is that what you're proposing we do?
Yeah, we can do that.
Like without an immediate wrapping component, they're just a hitbox.
Yeah.
Oh, okay. Polygon hitbox.
If you want to know the specific type of it, though, like whether it is a tree or or a house or something later, then it's good to extend it like this, because then you can name it here, and then in the collision detection callbacks, then you can check what the type is of what you're colliding with. Yeah.
All right, so I'm gonna keep that. I don't think we're gonna actually do this right now. Maybe we will. I don't know.
Yeah.
But
so
there we go. So now we just add this. We've added hitboxes. We're off to a good start, I think, maybe. Now we can start to turn on collision detection, which heretofore I don't think I've been using at all.
Yeah.
Do I need to put that on the game?
You can put it on anywhere where it is what you want as the root of the collision detection, kind of. So that is a mixing called has collision detection. So you can put it on the world, for example.
Okay. Has collision detection. Great. I'm not gonna lie. I always have to look up this part. It's like, there's a couple mix-ins. Which one goes where? What's the name of the callbacks?
So all the components, so the zombie, for example, could have a component that is on collision start.
Hitbox.
Yeah.
Do they need a mix-in for that?
No, not anymore. Oh yes, for the callbacks.
I'm on 182.
They need the collision callbacks as a mixin.
Great.
For reacting to it, and then we can add a hitbox to it.
Yeah, so that would
so
be
we can do that in the either in onload, or you can do it directly in the super thing there. But yeah, you're adding other things here anyway. So
what would the super thing be, like in the constructor?
Yeah. So then you can
it would just be
here. And then you do a list, and then you can have so I usually we have to look at, like, how do the zombies look like again?
They're squares.
What are their shapes? They're squares. So sometimes it's better with circles, because usually you don't have anything in the corners of the things. But
I'm fine with a circle hitbox. Yeah, that's fine.
Then do a circle hitbox. And yes, write circle hitbox there, and it will automatically fill the parent. So that's the only thing you have to do.
Great. Okay, so our zombies have hitboxes. Our unwalkable terrain has been converted to hitboxes. Now, unwalkable. Yeah, I don't think this is even. We're going to comment all of this nonsense out, I believe, but just so that compiles.
Yes, let it compile.
Yep. Okay, so now we're back in the zombie, and the theory is in update, we cache some values that we're going to use in these callbacks.
Yeah, so the first thing you can do in the update is say like last position or something. And then you just, and here you can do one thing that makes it a little bit more efficient, and that is just create the final vector 2 here. That is the last position. You can initialize it as 0 too. Then you the last position, you're still going to use it in there, but you're going to use set from instead of equals
I see.
position.
So final here equals vector 2.0. This is what you're saying to do?
Yes.
And then last position dot set from. And the reason this works, of course, is we're not reassigning the variable. We're internally changing its values.
Exactly.
Great. I wouldn't have done
Perfect.
that. Okay. And yes, our whole quest here is to reduce the creation of vector 2s. So that makes sense as a valuable starting point. All right. Now we do all of our movement, and the plan here is to get rid of the check movement stuff. So it was in chase, and then it was in move along path, I do believe. Yeah. And it was get unwalkable collisions. Nope, that's not what it was.
So I think we're gonna be able to reuse a lot of the code that you have written here, but not call it as often, kind of. We only have to call it once it collides. So if we go back to the zombie, we can just see that we get collisions first.
Okay, that's a good thought. I hadn't even found the code to comment out yet. One thing I've been lamenting on this stream in the past is that I don't think I have a very well organized or structured zombie class. And I don't have enough experience with games to know. Oh, someone was telling me about the flame behaviors package.
That was probably Joachim or Eric. Probably Joachim.
It was. Oh, gosh, I'm sad. I don't think it was them. I think I would remember that. It was someone else.
Okay.
And I'm sad that I'm forgetting their name to give them credit again. But I'll probably have a stream in the future where I explore that package, because I know that this code is not wonderful. But anyway, that's not today's quest. Today we are adding right now we're adding the collision callback to confirm that they're happening. And that was that's on collision.
So we can do on collisions. Yeah, we can do on collision start. So because on collision is called every time when you're still in a collision. So that would work for this one too.
I see.
But on collision start but we're going to move them away from each other when it happens anyways.
Yeah. So if we correctly move them away from each other, then in theory these functions should be called the same amount of times, because they can't keep colliding.
Yeah, exactly. So we have to change velocity a little bit.
Yeah. Okay. So on So on collision start, we've got our intersection points and then the other position component. And so what we want to do here is undo
so we can start with just making a print to see that our hitboxes work, I think.
So this was, we'll just print, I guess we'll say this is colliding with other. And do want to remove the checks so that things actually collide.
Oh yeah, sounds good.
So I'm going to comment these out. This means our frame rate should be good again.
Yeah, can move properly.
Oh, I have problemos, I think.
Oh yeah, you have all the prints left from the...
Oh yeah, the player also calls that method. And we're still passing in the stale parameter. Okay, so we're crashing.
Okay, it's very angry.
All right, so the problem is shape hitbox needs a position component ancestor.
Oh, it is because it is right. I think this is fixed in a newer version than the one you're running, but so right now we're adding it directly to the world, right?
Yeah.
And it doesn't have any sense of
where the heck it is,
of a size or anything.
Okay. So should I go back to the old polygon component and then add this hitbox to it?
Yeah, why not? That's the fastest. Let's go with that.
So we go to the polygon component, and then we can also say super children, and this would be a polygon hitbox that would take the same vertices.
Yes.
Why are you...
Or no, it wouldn't actually, because the polygon hitbox here is in relation to the polygon component.
So what I've written is going to break. That's what you're saying?
Yeah.
Okay, I don't understand.
So imagine
why this is going to break.
Yeah, so you're creating the polygon component first. And like when we added an empty circle hitbox on the other one, it would fill that one up. So everything that is done in the hitboxes is done in relation to the parent's position and size. Yeah, exactly. Right. But maybe check polygon hitbox what more named constructors it have. Maybe it has some
relative
things for us here.
So the relation, and then it doesn't take vertices in this one. Wait, so in the original, vertices. So what is relation? Super dot relation. Do you remember what relation?
Oh, yes. So that one, the relation is, so if you look at the example thing there, so if you write 1.0.0.0, it will have 1 point that is fully to the width of the component in x-axis, and then -1 will be to the other side, and then all these points together, they form the polygon.
Assuming the polygon has 4 points.
Yes, you can put as many points as you want in there. It's a list.
Right. Yeah, just in this example has 4.
Yes,
so
exactly.
If we just want to map to our exact thing, would we provide a relation that's like a bunch of what, ones or zeros or?
Yeah, so then we would have to calculate that somehow from our vertices, because the other hitboxes, they have so that you can just pass in nothing and it will fill up the parent. But since the polygon, if you have a polygon as your parent, since you can have any component as your parent, it doesn't know that it's a polygon and can't fill it up. So I think to start with, we could just skip the polygon things and just add a rectangle hitbox or something to just make sure that it's working, and then write a to-do that this should later be a polygon hitbox.
Okay, I'm willing to do that.
So you can just write it. Yeah.
Make this work, but the vertices values have to be made relative. Right now they are absolute.
Yes.
I'm telling myself I'm gonna fully remember this in the future, but I'm gonna come back and be like, this was a bad comment.
Yeah.
All right, so I want a circular
or
rectangle
hitbox. I think the house and stuff will probably look pretty weird.
A little more rectangle.
Circles. Yeah.
Okay.
Perfect.
Now, is this going to be able? Does a polygon component does it like figure out a position from these?
Yes.
Great.
A position and a
center
size
of them or something. Wonderful.
Yes. Or it depends on where your anchor is, I think. Where
for me, I always use center.
Yeah. We can turn on the debug mode and see where everything ends up.
Actually, I did not. I always use anchor when I remember to do this. When I know how to type.
Exactly. That's. I wonder.
I'm double supering. This
double
is
super.
Very silly.
Very super. Super 3 times.
Mm-hmm. All right. So we now have converted we did not change the unwalkable component. It's still a polygon component, but we have added a hitbox to it. And that was to fix this runtime assertion error. So now there's still a problem. Unwalkable hitbox.
Did you rename it again?
This is now component. And then we'll probably need to do, component. Okay.
Back to what you said from the beginning, and I told you not to do that, and then I was wrong. Okay.
Well,
so then we
60 FPS.
Yeah, and we see instance of zombies colliding with zombie.
Yeah, perfect. Okay, great. And they're not. Are they going to collide with the place? They can't walk in this yet. Oh, they can. Great. And we're seeing unwalkable component. Wonderful.
Perfect.
Wonderful. Okay. So this is exciting. And that means in zombie,
we have to do some
here
on collision start things here, and we can have a look at what we can reuse in your old. Maybe in the unwalkable component. If we want to do not rewrite so much code, we can in the unwalkable component that you created, we can store those vertices there directly, because the unwalkable component, those are static, right?
Yeah, but that the only time we were looking at the vertices was for zombie pathing, and I think that wasn't the issue. It was only the collision detection. Yeah, so rerouting the zombie doesn't seem to be the problem. It was just it was the inefficient, it was the components at point powered collision detection was the problem. So I don't think we need to worry about the vertices. I think what we need to do is basically get this same, undo their motion logic if there is a collision.
Yeah.
So I'm going to add a new method here, and this is going to be what signature is going to make sense here. This is going to be, we'll call it like clean up movement. And I actually write a doc string here. If
a doc string has 3 backslashes or slashes.
It does. It does. True. If collision detection reports that this component has collided with another component, that would invalidate this component's movement this frame, we use cached values, which the type checker is probably going to complain about not existing. We use cached values to undo the invalid portion of this frame's movement. I don't normally write doc strings that I think are going to be that good.
So I think you can move in. You had this last position inside of the component, right? I think you can move that into this mixin. So we have access.
Oh, yeah. Yes. That's brilliant. Last. Movement. There we go. Okay, and then we're going to have to make that change to the player as well, which I'll do right now. So in the player's update, do the same thing. Okay.
Right, and the player doesn't have a hitbox now, I think, right? So the player won't collide with anything.
Yeah, player's we'll call that the climbing API, as the player can just scoot up houses.
Perfect.
And then we'll add hitbox to it. Okay, so this whole on collision start method should also be on this mixin, right?
Or we just from the on collision start we call that cleanup thing.
Yeah, I guess because the player can probably move through zombies, or you'll just get surrounded. So they'll have different logic from each other. That sounds good. Okay, so what signature are we going to want here? We already know the last position, and we're going to need to know movement this frame, I believe. And
so movement this frame we already have. It's a position position minus last position.
And are we worried about creating this vector? Probably not, huh? So
yes, we are. So do the same thing here too. Create another movement this frame underneath the last position there, and then we can set that one.
That's just wonderful. Just wonderful. So we don't need to pass this in. Now the predicate, I think we will want to check what the hitbox is.
Yes.
But this will not take a component anymore. It will take a hitbox. No.
We'll
take
the hitbox component. Parent, I guess. It gets the parent. So it can take the component.
Oh. Great. So the component. And I don't remember what debug did. This might not even be a thing anymore. It isn't. Great. So, okay. So now, what do we need to do here? Oh, first things first, we need to actually make movement this frame be updated like we have with previous or the last position. So last position dot set from. So when we calculate movement this frame, we're going to do the same thing. So movement equals, yeah, so what is this one? Move along path. So we get the path of the player. We do some veering, blah, blah, blah. Oh, apply lurch movement. Oh my God. See, this is where this code stinks. It's not good, I tell you. When is the movement done being modified? I don't know.
So what you can do is just do this in the end of your update method to set the delta. So you have the last position in the beginning, right?
Except, oh yeah. That's super smart. So in update, what you're saying is here we say movement this frame dot set from, and is this going to create a vector that we internally?
No. So first you do set from position, and then not like that. That will create a new vector. So that's the terrible thing with game programming. You can't write all the nice things. The code always looks much worse because you have to think about so much performance. So you do the set. You can do a dot dot on the set from, so the cascade operator there, and then just set from position. And then after set from position, you do a dot dot sub.
I have no idea what this method is.
It's subtraction.
So this is last position.
Exactly.
Okay, so movement this frame. We set from our,
we got this the wrong way around, right? We should set it from last position and subtract the position, I think.
Oh, we'd have the inverse movement this frame vector. Yeah, so set from last position. That was where we started before, and then we subtract. No, I think didn't we have it right before?
No, we had it right. Oh, sorry. Yes, we did have it right.
I'll tell you, whoever it was, King Hater, when we find the professionals, we'll let you know how they are, okay? But for now, you're stuck with us. You're stuck with us. Okay, so movement this frame is now set, and I'm going to do the same thing in the players update method, and I have got to clean up the chaos that is how my I don't even know. I've got to clean up the chaos of how the zombie calculates what the heck to do each frame.
Yeah.
Okay, so both of these are now ready to go. Awesome. And we have our current position is still updated. Oh, wait a minute. So I should, every time I update the predicate, right? So every time I have like position change, I should be doing set from and subtract and stuff like that here as well, right?
So when you set position there directly, we override that equals to and do it for you if you're using the built-in position.
Oh, yeah, cool. Yeah. Smarty pantses. Great. So we need to now kind of start doing this code, except, so we're going to we get the new anchor.
Mm-hmm.
So let's start with the same thing. We'll just check up and then copy and paste.
Yes, we can check the predicate first to wrap everything, since we only want to do this if the predicate is true, right?
Yes, and I also need to pass in the component we're colliding with.
Yeah. Otherwise, we don't have anything to check.
Component, other collision, other. I'm not sure what to put it. Colliding component. That's what we'll call it. Colliding component. Okay. So so we check. So if not predicate dot call component. So if the thing returns, what's your problem? Oh, colliding component.
Yeah.
I'm so
and
good.
You don't have to write call there actually. You only have to write that when you're passing.
And it's like nullable or something. Yeah.
Yeah, exactly.
Then we just return. We return. Oh, we don't need to. This will probably be void now.
Yeah, we'll do everything in here.
So we just return. Okay. Now, if we're moving up. Also, does this strategy like make sense to you, or are you immediately thinking of a better way than saying if we're moving up, like figure out if we need to zero it out?
There is something called the normal of the collision.
Okay.
But I think we can skip those kind of things now because it gets kind of complicated. The problem we will have now is that we don't really have any velocity, right? So we will just keep on bouncing into to whatever we are crashing in. Now your sound is gone.
Yeah, I muted myself to clear my throat,
Yeah.
and then I'm so good at this, I tell you. I think it's okay. So I'll clear my throat with myself unmuted. I think that's okay because if it's an unwalkable terrain, then we should have already steered around it. If it's another zombie, it's also trying to walk forward. So eventually it'll get out of our way. So I think it's fine.
Yeah, let's start with this and see what happens.
Okay. So if we're moving up, then what we need to do is figure out, we kind of need to replace this, position of anchor. That's the same.
So I don't think you need the new top thing anymore, right? Do you?
Oh, right. No, that was to look something up. So yeah, we would say position equals a last position. And then here we're going to sub. Oh no, I don't want to make a new vector here.
So what you can do here is that you only want to change y here, right?
Yes. And I just set it to 0.
Actually, what if two zombies are running into each other from two different directions?
That's extremely unlikely, but I think that's fine. I think we just want to sub. Oh, I don't want to make a new vector too, but we're doing everything else so much more efficiently. But what if we said 0 and then it was movement this frame dot y?
And do you know what this is the same as?
Oh, and I typed
this is the same as position.y equals to movement this frame dot y. And I guess you want to have minus that one. And then you don't have to create a new vector.
Position.y equals. No, I want last position.y, right?
Yeah.
Yeah, this is how we zero it out.
No, you want the delta. Oh, okay, you want to, yeah, sure.
Zero it out.
Then we move completely out of it. So an optimization we can do here later, or not an optimization, but so it becomes more precise, is to calculate where
how far we
could
have gone.
Yeah, exactly.
Yeah. So now we just have 4 of these, and if y is less than 0. Oh, so here we could also say, if this time we just say if y does not equal 0.
Yeah.
Right.
Yeah.
We're done, and we don't need that. And then here we say if x does not equal 0, and so this is now moving up or down.
And you don't even need these checks, actually. I realize now, because if you haven't moved,
then we don't care.
Yeah. So you can just set position.x and position.y, and then so then you could set position equals to last position too.
How is that true? How is this correct? This feels like it shouldn't be right, because we should be able to move the other direction. But here, if we're colliding, we don't get to do anything.
Oh, true. We have to check that. Yeah, we have to have the not. Yeah, you're right. We need a not equals to 0. It will still be problematic when we.
But no, you are right that there's some other gap in our logic, because if movement this frame equals 0, then we know they were already the same.
But it was only the same for that on that angle, though, right?
But then that's true all the way down.
No, because you can move, if you only move left, then you won't go into the Y one here, right? But you will go into the X one and reset it.
So if we're only
hit something to the left.
Right, but if we're only moving to the left, then movement that this frame movement this frame dot y was already 0, so we weren't moving up or down. So if we're only moving left, so the scenario that I think we're maybe not correctly handling now, and maybe I wasn't correctly handling it before, is if we're moving diagonally, and one of those vectors is actually okay, and the other vector is not. Oh, yes, this is the problem.
Fine,
This
right?
is the issue. The thing is, we're not checking the direction of the collision. And that's what was happening before when I was looking up a component on a side of, right, because if I'm colliding on the right, but I'm moving left, I want to still move left.
Yes, you're completely right. So
that is not being,
yeah, that is what you need the normal for. But you can also, we get from the collision detection, we get which points it colliding. And then we can use that to see where that is in relation to the player.
So this is where we're going to say clean up movement. And the colliding component is other. The predicate, we're in zombie right now. So this will just be is zombie. And now we need to add the intersection points to the function signature. I think that's what we're concluding.
Yeah.
And then back in movement, we copy the thing that they are. Okay. Oh, hey, Lucas, we made ROAs.
Yay! More friends joining the chat.
We made it better. They may have already been made. All right. So the intersection points are now being passed into cleanup movement, and this part of this method I think is going to be interesting, and I'm looking forward to your assistance. So the intersection points are passed in, and here is where we kind of need to say, like, if pseudocode would be like if intersecting on top, right? We're moving up and we're intersecting on the top of ourselves, then we don't move up anymore. And then we'll do the same thing for, and it's not greater than or equal 0 anymore. It's just greater than, or it's not equal 0. So this is y is, actually we want less than 0 for moving up. And then I want greater than 0 for moving down. And then this we'd say like intercepting on bottom. And then we 0 out the y. Yeah, this is what we need, I think.
But we do need this for a more advanced collision detection system. But do we need it now? Because when we're going down, and if we're, you said we are assuming that, like, if a zombie is going straight down and into the house, then we know that the collision will be in the bottom of it, right?
But the problem is what it used to be able to do is like slide along the house's wall and still move left or right. Whereas now it will just stick to the wall and never move.
But if we know that it goes down with the movement this frame, x is equals to 0, and we only set we only set the x position when that happens. It can't slide against along the wall, right? So I think your code before was correct. I think it would have worked.
So what I think happens, imagine, yeah, so there is that, like, we zeroed it out and we could have just reduced it. So there's that problem. That problem has always existed and I've just lived with it.
Yeah.
It's generally like a pixel or two in a frame or something. And it's like, I can't tell. Also, the collision detection is sloppy enough that I kind of clip each other sometimes. So, significant digits kind of coming into play. But let's say the zombie's on top of the house and the player is on the bottom of the house. And so the zombie wants to path straight through the house to get to the zombie or get to the player, but can't, of course. And so it's like pathing toward one of the corners because that's the other function in play. And then it eventually gets to the corner and it clips the house ever so slightly. it would have all of its movement zeroed out. If we don't detect like, oh, the zombie is clipping on the bottom
Mm.
and it's trying to go around the right side of the house. So it's clipping on the bottom left.
Yeah, but it
We
will
would-
never, since we move it back to where it was the last frame, it will never be stuck on clipping. It will always move
Unless
out
it just
of
tries
the
to make the
collision.
same movement again. No, it'll just try to make the same movement again, unless the player
Yeah.
moves.
Yeah. But isn't that happening now too? Oh no, but it's moving towards a corner now. Yes.
But they would
why do you-
slide along the house before, because they would only lose the component of the vector that was causing the problem. So if I'm clipping
Yeah.
on the bottom left, I can still move to the right. I can slide along the wall to the right.
Yeah, but if we have the ifs that we had there before, if movement this frame dot y is equal to 0, then it will continue to walk in the x direction.
All right, let's run it.
Let's run it and try.
I think it'll get stuck, but let's find out. So I'm going to comment this stuff out.
Oh, great. You had the other thing already underneath.
So here we say if it doesn't equal 0, and I believe we correctly concluded that this code is equivalent to this code, right?
No, that was wrong. You were correct there, that we need both. Because then it will definitely cancel out both movement. So I think this...
You're saying we still do this part?
No, not equals to 0 on both.
Oh, not equals to 0.
So if we have movement in the x-axis, then we need to move back to the last position.
Yeah, I don't think this is going to work because it's going to zero everything out unless it was already 0, in which case it ain't moving in that direction. But we'll see.
But how? Okay, but you have other logic for pulling it to a corner, right?
Yes, so I think it might get stuck on the corner. I'm going to go down to 1 zombie so we can really focus on what it's doing. So in the world,
a mess.
Yeah, what's happening? Okay, 1 zombie.
But the zombie is only colliding with the zombie now, I think, right? Isn't that your predicate? So we need 2 zombies.
Yeah, we absolutely have to do this again for the unwalkable terrain. And that was in zombie. Where's that? So here we go, clean up movement. And this is unwalkable. Oh, is unwalkable terrain. Okay.
Right. And we added hitboxes to the unwalkable terrain too, right? Yeah, that was the polygon ones.
Yep.
Good.
All right, so we have to find the zombie. I'm going to lower its spawn radius in the next one. Okay, I'm lowering it now. That's in world.
Wandering around somewhere.
Yeah. Okay, there's the zombie. So let's see what happens when it
went straight through the hitbox. So
I think because it was a circle, so it's not getting stuck like I thought it would. And yeah, I did not think it was going to slide along the... That's exactly what I thought wouldn't happen.
Yeah.
And I still don't know why it's happening, because I still think the code we wrote prevents this, but I'm obviously I'm not thinking about something correctly.
But if you look at like now it's moving. If you stand on exactly the opposite side of the house, then it will get stuck, I think. Yeah.
Which is tough to do.
Yeah, it doesn't matter really. I guess this, like you said before, the zombies can be stupid enough for that.
Yeah. Zombie derps are okay for sure.
They're walking inside of the house though, and so if you turn on debug mode for the zombie, I think that the zombie probably doesn't have a size.
It does.
Okay.
Which I can prove to you.
There it is. There is the size. Okay, turn on the debug mode anyways, and then we can see the hitbox there.
I think so this debug does something different. It draws the path that they're going to take. So we basically just want to go back to game and do the big one.
Yeah, you can set it on any component too if you don't want it on everything, but I think it will be fine.
Really?
Okay, that's okay. The hitboxes look all right. They're a little bit big, but
Oh, well,
now
that
it's just walking straight into the house.
But like only. All right, so there is a gap in this logic that we just hastily refactored. It like kind of catches, but there's a leak somewhere.
It is going halfway through the house.
Yeah, why is that happening?
Yeah.
All right, let's think about this.
I don't see the hitbox of the house though.
Yeah, the hitbox of the house is probably covered by the red lines.
Rendering. Yeah, probably.
But would that get its own component? Would that? No, something's not right.
Yeah.
Something's not right. Let's go back to the world and review how those are added. Yeah, we made that a square instead of a perfect polygon.
Yeah. Yeah, so then we should have seen it.
Yes, we should have. So we're adding to the world. This is in onload. Yep, and we're in the world.dart file. So we're adding to the world the unwalkable component. Oh, I can also get rid of these red lines. They're just visual. They don't do anything for game logic. So then we'll see that there's definitely no.
Okay.
This is super weird. So the unwalkable terrain, it still exists, and its hitbox definitely exists, which is the only thing preventing. Oh no, wait, the player. Man, we're really in like a terrible mid-surgery state right now.
Yeah, that's the classic.
Yeah, the player is still checking movement, which is the old method.
Right.
And the player is not. We got to move all this into the mix-in. The player is not doing. Let's see. Did I put this in the player's update method? The one for the bottom. Yes, I did. So that's got to move into the mix-in. And then in the zombie, we have the collision detection on collision start. Not doing that in the player yet.
Yeah.
So the player's check movement is now commented out. Oh boy, this is so gross. Gotta have a cleanup episode here. Okay, collision. I gotta add the mix-in to the player. That's collision callbacks.
I'll be back in 30 seconds.
Okay. How quickly can I break everything while he's gone? So collision callbacks, probably have to import it. Okay. So now the player, I was just finding it. So the player doesn't care about zombies. The player has to be able to walk through zombies, but does care about the unwalkable terrain. I'm going to check chat here. Randall, wow, Randall, you have been paying attention. I think you just need offset position plus offset velocity is not within the rect of the game board. So there is separate logic to not walk off the game board. Can you say more? Can you say that again, Randall, in more words? And then you may need absolute reference over X and Y with a simple shift. I'm not sure. I'll have to think more about that. Someone asked, is this open source? And that answer is yeah. Not that the source is good enough that you should find this answer valuable, but yes, this is where I push a branch at the end of every stream with whatever I did on that stream. And so far, I have been a dutiful streamer and not worked on this off stream, though every Thursday afternoon I want to. All right, so the player's code has now been updated to match the zombie code.
Perfect.
So the player is now also able to just go
straight through the house.
Totally crazy. Yeah.
But did you add the hitbox to the player?
Probably not. I'm certain that I didn't actually. Actually, I'm not certain about anything in this code because it's way too messy and very hard to reason about. But I bet that I didn't. So this would be a rectangular hitbox, do I need to say?
Yeah.
That's not right.
It might be small b.
Oh, it is. Yeah. Okay. Now the player maybe can't do that. Nope. Totally can. Let's check out the players
if
on
there,
collision
it doesn't
start.
look like there is a hitbox there on the house. That hitbox is somewhere else.
Right. That was the problem. Yeah. So that's back in world. So here we have our unwalkable component, and the unwalkable component does add a rectangle hitbox. Does this maybe have no size?
So that doesn't need a size. That one automatically becomes the size of its parent. But I think the position is the problem, maybe. If you go further up to the, or wherever 0, 0 is in this world,
why
is it in the middle?
0,
why
0,
is it working for that one? I think the zombie must still be using some of the old logic. Because there is no hitbox there.
But they're not, because check movement was what did it. Oh,
what
no,
about
you know
this
what they
veering thing?
No, you're on the right track. It's get unwalkable collision. And all of this nonsense that changes path to player. So if we comment out this, now the zombie will do whatever they want.
Now it can walk straight
and that's why
through.
they're gonna not care at all anymore. So that's why they were kind of clipping, is that they were pathing to the corner, and then they would path to the next corner, and then they would come down.
Right.
So absolutely nothing is working right now, and it's likely because the house has no hitbox.
So we can start with checking just that we get collisions. So check if the zombie is colliding with the player and just print something.
Okay, so we did get rid of this. So the zombie is now going to say zombie colliding with other. Refresh. So, it did. Oh, that's interesting. Unwalkable component in the base of the tree. Yeah. Yep.
Oh, they are underneath your tiled component, I think. Really? Does your tiled component have a priority?
It's not mattered before the order. Yeah.
Interesting.
Okay, so
wait.
Tiled. So here,
add there. Where are we now? Which is this?
We're in the world.
This is in the world. Okay, that is correct.
Yeah. So we're adding the map and everything, and I'm not setting the priority here. So unwalkable component. So we could add to its super a priority value of, what's the default priority?
0.
So something higher. Hey.
And, there they are.
And they have a colored background now. Why is that happening? Is polygon component doing that?
I think you have set your debug paint to something, maybe.
Okay, I'm going to turn debug off and see if that goes away. Gosh, this is just like such mad science right now. Zombie game, debug mode off, refresh. So it's something else.
Oh no, it's your polygon component. So if you go to that the one we created, unwalk, exactly this one, and then I think if you go in and check in it, I think it has some form of render thing, maybe
shape component.
Otherwise we will render shape there, set that to false.
Render shape, yes. Wonderful. So that's just a field, it looked like. That's good typing. Was that in the constructor?
I don't think so.
No.
So yes,
where did render shape come from? Bool render shape. Oh, yeah. I wrote like some Python level stuff. That's what we have to do. What are you whining about? Field overrides a field inherited from shape component. Okay. Refret. Nope. Type capital R in the game file. Okay. So now we are getting collisions.
Zombie and player are getting collisions. Or did you collide with a house too? I don't think so, right?
No, we did
What
not.
about with
the tree? That worked.
The trees. The tree worked.
We saw it before. Yeah.
Yeah. Okay, something is strange with the house. Oh, look, there is something small there up in the left corner of the house.
Oh, right. I gave it a hard-coded size because I'm super smart, and I thought maybe its size was 0.
Right. I forgot that. Those are the things, like, if you would have forgotten that one now, and then you do another episode about this in like a month, it would have been like, what? Where did this come from?
Also, where? Oh, here we go. So size goes away, reset. Okay. We can see the rectangle around it.
Mm-hmm.
And it clipped and then walked right through. Awesome. Okay.
Okay, check that we're going into the predicate thing, or you're doing like one of these early returns, right?
Yeah.
So check that we do anything underneath.
All right, so we're in zombie and we call cleanup movement. That is the correct method. Check movement was the old one. And we're not even passing in the intersection. Oh, no, we are passing. We're just not using them. So is zombie, if the predicate returns false, we return. So that's fine.
Yeah.
And then I don't know.
Yeah, sounds like a good plan.
It's close this time. Okay, this seems fine. It has actual values. And now let's so position. I'm going to print position minus last position for what our movement ended up being.
Mm-hmm.
Print final movement is going to equal position sub last position. Is that actually going to do? Is that an in place thing? I'll just do this. We don't need to be cute in our print statement.
No, exactly. Yeah.
Okay. Close again. Yeah. Terrifying. So final movement, it keeps saying 0. Every time it seems to say 0. Let's give ourselves some more breathing room on these logs.
Yeah, because we always walked in both directions.
Yeah, so that's what I thought would happen.
Oh, right.
And, there is some final movement. Sometimes, I guess.
Yeah, you're right. We had to calculate that one. But why are they not stopping then? They're not even stopping.
So here, I think final movement stays 0. That's probably when it's. Oh, no, we see it was just hitting with unwalkable component. There's just bugs everywhere. That's the problem right now. There's just bugs in this hastily thrown together implementation. But yeah, so movement.y is, we're setting it back. I'm pretty confused here.
Is our last position must be the same as our position for. Okay, can we print the. Oh yeah, we're printing out movement is frame, and that one is clearly something.
Yeah, initial post movement position is going to be the position, and then the post cleanup position is the new position. Let's see what this is all about. Okay, so we're moving along, we're driving along. Okay, so I'm going to scroll up here. So this method happened once because it was just the start of the collision with the unwalkable terrain. And so it went back an ever so tiny amount, which, seems basically reasonable for one frame that we were moving this really small amount. And then
do we have another position in here that is shadowing the real position?
Don't think so. Do we have one in the component?
So we set the last position there. And then we add movement this frame no matter what happens. This is our update, right?
Yeah. So this is this is
That
the
should
whole
be fine.
point. Yeah. This is why we're able to why we're trying to clean up position and why we're using the position as the post movement. Yeah, I wrote that in the doc string. If collision detection reports that this component has collided with another component that would invalidate this component's movement in this frame, we use cache values to undo. So we've already applied.
Yeah.
So position equals position.
Randall thinks that we should start doing two string overrides instead of writing our own prints. Good point. Good point.
Yeah, I don't think we're shadowing it.
No, I don't think so either.
So could it be a thing where, all right, let's get real crazy here. Collision start. What if instead of collision start, it's just collision?
Yeah, let's try that.
Must call super.
Yeah.
Okay. Definitely still. Wait a minute. I saw some weirdness there. Oh, I think it had the same movement for a while because the zombie takes a step and then like stops before it takes its next step. And so there it was just, it kept colliding but not moving.
If you scroll down a little bit there. Not in the logs, in the code.
Okay. Let me lower this then. What are you looking at?
We're not doing anything. Oh, yeah, clean up movement. Yeah, sorry, I'm completely blind. Why? Why does it not reset? It must be something wrong in the update method, I feel.
Okay, so update.
Set the last
We got our last position. And then what do we do at the end again? Oh, that was movement this frame. Let me just... And then how do we use movement in this frame in here? We were planning on it at some point. I don't think we did. Oh, we did.
No,
we definitely did. We made
yeah, right. But
super duper use of it. Position.x equals last position.x. Yeah, that really seems like it's correct. I mean, I still think this code is buggy, but we haven't even been able to get the bug that I think it will produce. So it's double buggy.
Yeah.
I think it's broken and not working. All right, so we get a bunch of movement in this frame 0. I'm gonna just get rid of that.
There is a is0 in there too.
Oh. Method, I guess.
Oh, it's yeah.
All right, so yeah, we're walking straight through. All right, what do we expect to see here? We're getting, yeah, we're just getting non-zero values, so that's fine. Seems good. And it pauses printing when the zombie's not stepping anywhere. Initial Initial movement. Why did I think that sentence made
You said initial post move, but you wrote initial movement.
Nice. And you just let me go with that. Okay. So that's one of the things that's also pretty hard about game development, I find, is whenever you add one of those print statements, you immediately get such a mudslide
Yeah.
that you have to like stop and reason about what's happening.
There is Dev Cage has written a really nice, so that is a super active member of our community. He has written a really nice thing so that you can just step forward frames in the game in debug kind of way. So then it doesn't just print massive amounts, and it becomes a lot easier to reason about it.
Holy
but
smokes!
Somehow we are not changing the position.
Yeah, I'm going to restart this, and I'm going to then kill the game at some point so we can just look at values. Okay. So post movement position is not being reduced here. And well, that's one of the great parts about killing the game is I can't go back and see if it should have been. It was on the bottom left part of the house, and it would have been clipping on X. Wait a minute.
These are all the same, right?
Yeah, so this would be like, we're zeroing it out. The code is working. This makes me think we're back in the shadowing problem again, but I don't know why.
No, but post cleanup, this is the position after we have moved, right? And we're not setting.
Oh yeah,
the last
it's actually
position
changing
thing
nothing.
It's
changing nothing.
Exactly.
You're right. So movement this frame. And obviously this print is after the predicate, so that's not the problem.
Yeah.
Movement this frame does not equal 0. We're gonna like cackle, I think, when we find this.
Yeah.
What a bunch of goofs.
It's always the simplest things you get stuck on, right?
All right, we're coming up on time here. Hopefully we have a breakthrough soon.
Yeah, soon we'll have it.
There's so much terribleness right now. I may do off-stream cleanup and just have a branch that shows the work. Because the code is tremendously terrible. All right, so it entered the house, so now I'm going to kill the game. So it's saying movement of nothing. So that is our problem because we're not getting in these statements.
Okay, let's check where we set movement this frame then.
That was in update of the zombie. So we're setting from the position, and then we subtract the previous position. That absolutely seems like it should be correct.
But we don't do this for the player, right? So that is why we don't see it in the player, at least.
Correct.
Maybe we should remove the zombie for now and just have the player so we get a bit clearer logs.
Okay. All right.
So that, because then we can like intentionally just walk into the house and
yeah, that's super smart. So 0 zombies. And now the player does have movement this frame printing. So I'm going to actually just close the zombie file. Player is, and then in its collision method is checking for unwalkable terrain. All right, let's try it and see what we get. Oh, there's actually an interesting question here.
Yeah.
Great point.
If we still only have that little FPS, I think it's something very bad.
All right, I will do that in just a second. I still want to. Andy is really onto something. I mean, we're currently working on the correctness implementation of the performance fix. Have not verified that the performance fix is a fix. Okay, so I'm going to make this smaller so we can really see everything. So when I go down, we get a value of exactly what we expect for movement this frame. So this is not 0 when it shouldn't be 0. Great.
Yeah.
So now clean this out and walk in. Okay. So already got just a bananas amount of print statements. So we had our movement this frame, moving to the right, positive X value. Initial post movement position was 610 gobbledygook with movement 0. Immediate.
We printed it before.
Yeah,
we have two.
absolutely.
We have two different variables. We have one inside of the mixin and one inside of the player, probably.
Oh god, that would be just devastating. Where did that? Here we go. Movement this frame. If that's it. Oh my gosh.
Oh, that was not even something we created now. That is something from before.
Oh my. Freak, so that's what we updated. Okay, so what we're gonna name this cached movement this frame. Oh, things are just so gross. Cached movement this frame, and that's this. Oh my goodness, what a nightmare. Oh, it was shadowing all along, but we were that's going to be at the end of update.
And this is like when you don't care about variable names and stuff anymore. You just like, oh, it's I don't know, are you doing the advent of code?
I am not.
So that you have here the problems are released at 6 in the morning, so you really don't care about anything except for getting it done and getting it out there. Talking about that, we have a Dart leaderboard that we could share the code for if we have people watching that would like to join. So before Tim had a Dart leaderboard, but that one doesn't exist anymore.
All right. I think this has a chance of working in that it will be broken in the way that I am suspecting, but that remains to be seen. And then we just turn on 100 zombies and we see what's up. Okay. Yeah, I cannot move up. I'm stuck. I'm pressing right and up, and I'm just stuck. So a zombie wouldn't be able to slide along the house, although it did glitch in a weird way.
Right, but the player would be able to go in there and just press one direction, right, to move.
Correct. Yep. Yeah, you can stop. So I'm stuck here because I'm pressing right and down, but if I stop pressing right, then I slide down. That's for another day. That is what I was anticipating with the check-in direction thing. So if intersecting on top, then we zero it out.
Yeah, that sounds good. So what you can do there, for a hint for later, the simplest way, if you don't want to calculate the correct normal, is just you get a set of intersection points. You can just get the average of those intersection points and check it towards the center of the one that it's colliding with, and then you will get which direction it is colliding.
Yeah. All right, now we're going back to 100 zombies. I'm gonna not zero out their movement anymore. This is just insane. This is so bad. Zeroed out or commented to see zombies move. Obviously uncomment. Okay, so we're going to see 100 zombies move. And that was in world, which I closed. And they do all the checks. All they don't do is actually correct their movement. So that's fine. That wouldn't be a performance problem. We're doing the checks. And we'll see what happens. Little, yeah. So
Nice,
Lucas said in
nice.
chat, by the way, everybody, if you want to join the Dart Advent of Code leaderboard, that is your hash or whatever noun it is. That's your code.
Yeah, it's like an invite code or something.
All right, so I'm going to get rid of debug.
Oh yeah.
That's in game. Refresh. All right, 60 FPS.
Sweet. Okay, that's good. Then we know the culprit and there is a way forward to solve it.
And then it goes down when all of our print statements are flooding the terminal as they walk over the house, but that's also expected. And then once we get away from the house, it should go back up. It's not yet. Oh, they're colliding with each other, so they're still printing like crazy.
Yeah. Oh, there's a lot of print statements now with 100 zombies colliding with each other.
Yep. So let's just get rid of those print statements and prove to ourselves definitively. That's in movement, I believe, is where we're. We don't need these at all. I don't believe. Print, nothing else in here. In zombie, colliding with other. Yeah, we'll get rid of that. And then in player, print, we have this cached movement. We don't care about that. Okay. Restart. 60 FPS. They're walking over the house, staying comfortably at 60 FPS. All right. There's going to be a part 2 to this because I do want to see them not dogpile. And
yeah,
there's something
we kind of went backwards this episode, right? But
yeah, we've removed the logic from the last episode, and we have a theory that we can uncomment a couple things, add a few lines, and we'll restore all that functionality, but with performance. But I'd really like to see it because here now, I mean, we're even dropping down to 10, and this that shouldn't be happening. So there's still more optimization to be done. All right, Lucas, we have eclipsed 2 hours here, so I think it's definitely time to call it. Thank you for joining me here. We still have 50 folks watching. Just heroic attention spans from those 50 people.
For the 50 people, remember the game jam this weekend, and you can have as fun as we had now.
Yeah, you too can scratch your head and wonder why a vector is 0 if you just go to that link and click some buttons. All right, Lucas, any other thoughts on your end?
Oh, thanks for having me. It was a lot of fun.
Yeah, gosh, I love working on this game on the stream. Next week, I have a guest lined up who's been in the pipeline for a super long time. Schedules are finally aligning. I'm not going to spoil it, but I'm excited about it. I guess it'll just be spoiled by the thumbnail on like Monday or Tuesday anyway. Whatever. It's going to be cool. Not going to be game related, though I never tire of game development. Lucas, thank you for joining. Have a great rest of your evening. And everybody else, I will see you in the future.